The information today that we're going to go through is section 7.6. And in 7.6, last week I handed out to you some handout sheets that had story problems in those. You won't need them just yet because we're going to go through what variation means, but eventually we're going to end up doing some stuff with your story problems so we can start figuring out what's on your sheet with those. Today, just follow along with these, okay? You're going to have the examples of this probably on your sheet that I gave you, but just follow along for right now, and we will see what we can end up doing with these variations. Probably out of all story problems, if you get the definitions of what each variation means, because there's three. There's direct, inverse, and also joint variations. And if we get the definition of what they are, and you see that word, it's going to tell you what to do with that variation when you read your story problem. So it's kind of a look at what you have and come up with what you've got. So we got direct variation, we're going to have inverse variation, and we're going to have combined variation, and this one is also called joint variation. So it's got two names with that one. So if you see joint in there, that means that we've got that type of a variation. And these involve usually a multiplication and division or a combination of both of those. So that's what we're going to do for today. So first off, in our notes, we need to know what a direct variation is. And that is a variable quantity, y, varies directly or is directly proportional to. So you will see both of these words in your story problems. They will be there. It's not like any of these story problems are not going to have those words in them, because they will be right there. A variable x, if there is a constant k, and we're always going to have a constant term in every one of these that we do. And so that constant term, we always label it k. And you could label it something else, but it just means that you've got a consistent thing that you're doing there with k. So y divided by x is going to equal k. But the key piece to this is that it's a multiplication. So you're going to multiply with it. So it's going to be a multiplication where you're going to pull stuff together and multiply those two pieces. So they're a combination of things that you happen to have there. So it's a multiplication that you got taking place within those. And so that is the key piece. So whenever you see direct variation, it means to multiply. So we're going to always multiply with those. Okay, so that is the key piece there, and it's always going to be k is going to be our constant term. So let's look at one. This one's similar to your very first question on your sheet, but we'll get to that in a second. If y varies directly as x, and y equals 6 when x equals 2, find y if x equals 6. Now within this story problem, there are three pieces. And I'm going to highlight them in different colors so that you can get to see what those happen to be. This piece, the very first sentence usually, is going to tell you your equation. So this y varies directly. So directly means multiply. So that is setting up this piece. Okay, it's setting up y equals k times x, k meaning our constant term, and you always have a constant term in here. There is never any difference with that. Then we move from here to figure out what k is, and they will always give you, within your problem, they're always going to give you what your pieces happen to be with that. So this means I'm going to substitute 6 in for y, I'm going to substitute 2 in for x, and then I'm going to solve it for k. So all they basically did here was divide each side by 2, and they found out what k equaled. We good so far? Okay. Then the final statement that they give you is this one that says find y if x equals 6. Now what that means is we're going to take it and we're going to substitute 6 in for x down here into my original equation, along with what my k happened to be, which is 3, and solve for y. So we're putting in our 6, and then we're going to end up solving and coming up with what our value will be. Now this part's not real clear in my notes here, so we're going to wipe that piece out, and we're going to put in here y equals 6 times our k, which is 3, and we're going to find out that y equals 18. Okay, so y ends up equaling 18. And so each variation, once we find out our constant term, we can find a whole bunch of different ones and a whole bunch of things that relate to it. So if you always go through and look at your statement up above and break it into its pieces, first piece gives you your equation, second piece, or equation, now second piece gives me the values I need to find k, and finally the last piece tells me what my answer part was going to be and what the other piece will be. So there's 3 pieces to these. So first piece, the middle, and then finally the last piece. So if you break them apart, you're going to be good. Okay. In the online classes, I have stuff posted in my discussion boards that have all the same colors in there for your variations too with those. But anyway, so that's that piece. So direct means multiply. So keep that in your mind. Direct means to multiply with what you have. Now this one that we have has more statements to it. And sometimes you look at them and you say, oh, the wording is just beyond what my wording needs to be. But that same 3 pieces of information are in here. So if we go through and reread this, let's see if we can identify the first statement. It says a spring will stretch a greater distance as more weight is placed on the end of the spring. The distance d the spring stretches varies directly as the weight w placed on the end of the spring. This is a property of spring studied in the physics and is known as Hooke's law. If a weight of 10 grams stretches a certain spring 6 centimeters, how far will the spring stretch with the weight of 15 grams? It says assume that the weight is not so great as to break the spring. So over here we're kind of showing the spring, we're showing the weight being put on the end of it to see what happens to the spring and how long it happens to go. Okay, so if we go back up above and we identify our pieces. So now if I go back and reread this, this piece, this first sentence is just kind of verbiage. The second one though, the distance d a spring stretches varies directly as the weight placed on the end of the spring. What that is that's telling me what my equation is going to be. So if I write that equation into here, it's saying I'm going to have d is equal to varies directly, which means to multiply. That means I have k times the weight. So that's my formula piece. Okay. So then if I read the second line, it says, again, they give me some other information in there that maybe I don't need. It says the property of the spring studied in physics is known as Hooke's law. If the weight of 10 grams stretches a spring 6 centimeters, so that is the piece that's going to let me solve for k. So I'm going to put the weight 10, so it's going to be 10k. It stretches it to 6 centimeters. That's the distance. So you need to keep track of your letters in there of which one goes where. Solve for k. So I'm going to divide by 10. And I'm going to find out that k is equal to 6/10 or 3/5. So we good there? Yes? hopefully. Okay. So then if I go on and I read the next one, and the next one is my pink area. So in my pink area, it says, how far will the spring stretch with a weight of 15 grams? So now I need to go back and plug this part back in here, and I got to go back to my original. So we want to know the distance when K, which I found is 3/5, is times the weight, which is 15. So if I solve this, 5 goes into 15, 3. 3 times 3 is 9. So I find the distance it will stretch is 9 centimeters. Okay? So it's kind of, I think you look at these and they're actually easier than some of the story problems we've had to deal with so far. So just keep in mind, direct variation means to multiply. So if you see direct, it means to multiply in there for those. Questions with this one? Think we're good? Okay. Again, take it and break it apart. Don't try to look at each piece. So if you get those first sentences in there, those first sentences end up meaning something as we work through those. The next variation is inverse variation. What does it mean when we invert something, if you think of it that way? If you invert it, it means you flip it over, okay? So it says the variable quantity y varies inversely or inversely proportional to, again, you will see either one of these in your story problem. A variable x, if the constant term k is such that x times y equals k, or y equals k over x. So this is a division. Because if we invert something, we're dividing by it. So we're going to do an inverse in there. And again, constant k is k. And so that ends up being our part in here. So anytime you see the word inverse, it means to divide. So make sure that you do your division with those. Okay, so you're going to divide with that part. All right, so let's look at one. Inverse variation. It says if y varies inversely as the cube of x, and y equals a -1 when x equals 3, find y if x equals a -3. So if I break this part apart as well, I find out that I have y varies inversely as the cube of x. What does that mean? So that's the first piece. That sets up my whole equation. So y varies inversely, so that means I have a division, and always the constant k is in there. So you're always going to have k. The cube of x. So cube of x means I need x cubed in my bottom. So that's the first piece that this states, is it's looking at that and saying, okay, what is my value that I'm going to end up with? So then, if we look at the second part, and y equals a -1, my poor marker here is slowly dying, drying out death, I guess. So what I want to do is plug these numbers in. So y is -1, k is k, and x is 3, but I want it cubed. So I have a -1 is equal to k over 27. To remove the 27, I multiply both sides by it, and I find out that k is equal to a -27. We all good there? Okay. Questions? Because it said cubed, so I had to cube my 3. And then finally, the last piece says find y if x equals a -3. So then what I need to do is plug this back in. So I'm going to have y equals k, which is a -27, all over a -3 cubed, because that was my original statement. And what do I get? I get y equals a -27 over -3 times a -3 times a -3. What's that going to equal? Negative 27. And negative 27 divided by negative 27, y is equal to 1. Okay. So out of these type of story problems, again, inversely or inverse means to divide, and so we set up our first part of our question that way, and we get it as a division. Okay. About this one. The gravitational force between an object and the Earth is inversely proportional to the square of the distance from an object to the center of the Earth. Hence, we have the formula, and they give us our formula over here, which is F times d squared equals k. And where did they get this at? Which is originally this. This piece, I think, makes it confusing, because if you set this up based on what you have written in there, you will be good, and then you got to solve it from there. Okay, so and where did that come from? Well, that ended up coming from this very first sentence in here. If we look at that first sentence, notice it says the force F between an object and the Earth is inversely, so this is my key, inversely proportional to the square of the distance and then an object is from the center of the Earth. So that's the piece that we needed from that part. It says as the distance of an object from the Earth becomes larger, the gravitational force exerted by the Earth on the object becomes smaller. So we've got some changes going on there. To continue it, says if an astronaut weighs 200 pounds on the surface of the Earth, what will he weigh 100 miles above the Earth? Assume that the radius of the Earth is 4,000 miles. So we've got the force, which is 200 pounds, times, which they turn it into scientific notation here, but we don't need to, you don't need to do that. If you're working with your calculator, you don't need to turn it into scientific notation. It will handle it just fine without doing that. So then they figured this piece out. This is also 200 is equal to k over 4,000 squared. Okay. Now the other key with this is once you put that on your calculator, leave it on your calculator. Don't take it off, because we're going to use k again in the next piece. So leave k on your calculator. So don't pull it off of there. So what does that give me for an answer if I put that piece in there? So what happens to that? So I'm going to have 200 times 4,000 squared. And it's going to give me a really big number, and I don't know if I can get this where you guys can see it. Can you see it up there? No. It's always a problem with not having enough light with some of these things. But it ends up being 3200 with 1, 2, 3, 4, 5, 6, 7, 8 zeros after it. And that is what k happens to be. So then, once we find k, then we need to figure out what happens to his new weight when he's 100 miles up from Earth. So what does that 100 do? Well, that 100 ends up adding to the radius of the Earth, because now it's no longer 4,000, it's 4,000 plus 100. So now we want to know the force, and k was this 3, 2 with 8 zeros. That's why you want to leave it on your calculator. All over 4,100 squared. So we're going to take that number on your calculator and divide it by 4,100 squared. And when you get that, he's going to weigh, if he is off Earth, he's going to weigh 190.4 pounds. Will be his weight in space. So if you want to go on a diet, become an astronaut, get outside of Earth, then you'll end up weighing less. Kind of a bad way to end up losing weight, but hey, it might help you out. So anyway, that is the information from this one. So that's what you'd end up doing to it. And I think we got another example of that in your problems that you happen to have on your sheets that we'll get to here in a second. And then finally, the last one is a joint variation. And a joint variation has more than one piece that's happening to it. So there's more than one process on K. So K is going to have some different things happening to it. And again, if you see that varies jointly, that means we've got two things going on. And in most cases, it's two multiplications that are happening. So let's read our problem here. It says, if Z varies jointly as X and Y, so jointly means K is going to be times X squared n times Y. And Z equals 18. Oops, gotta get my green out here. Z equals 18 when X equals 2 and Y equals 4. So plug 18 in for Z, plug 2 in for X, plug 4 in for Y. Multiply those things out, come up with what K happens to be. So 18 divided by 16 is what they did in there. And once that's reduced, it reduces to 9/8. And then finally, we need to put that in for K and finish out our problem. So if we finish out our problem, we got to look at this last piece that's on here and plug that information in. So if we plug it in, we're going to have Z is equal to 9/8 times X, which is 4 squared, times Y, which is 3. So what do we get? We get Z equals 9/8 times 16 times 3. The 8 and the 16 will cancel. And I'm left with 2 times 9 is 18. And 18 times 3 will end up giving me 54. So Z equals 54 for that one. So jointly can mean multiplications, 2 multiplications in this case. Okay, so there's 2 multiplication processes that are going on in there. So you've got that combination of stuff going on. Okay, questions with this one? Are we good with that one? Okay, so we'll get that one out of there, and this was the extra piece of it that solved it. So we ended up solving it on the other page, but I still got it in there. And let's go to example here with another one that has our combinations of stuff in it. So if we read it, it says the distance an object falls varies directly as the square of the time it falls of the units hit the ground, assuming there's little or no air resistance. If an object fell 64 feet in 2 seconds, how far would it have fallen by the end of 3 seconds? So our time is what's going to start changing in here as we start going through this one. So again, our sentences, directly as the square of the time it falls. Then, if an object fell 64 feet in 2 seconds, that's our piece that lets us solve this part. And then finally, the last thing that we have in there is how far will it have fallen at the end of 3 seconds. Does that make sense? Hopefully. Okay. So again, you set it up. You get your pieces. Varies directly, so we know it's a multiplication. Plug in our 64 and our 2. And you get 4 out of here. Divide 64 by 4, it gives you 16. So that's what K would equal. And then you would end up finishing it up and taking X is 4 and Y is 3. So, whoops, that was my other one. I guess we got to finish it on here. So then if I finish it, how far will it have fallen at the end of 3 seconds? So I'm going to have distance equals 16, which is K, times 3 seconds squared. So 16 times 9. And I will end up with my answer of D equals 144 feet. Okay, so 144 feet would be what we'd end up with for that one. Okay, questions with this one? Okay, let's go, and I had some more in here, but let's go and take a look at your story problems that you guys have in front of you. And let's see if we can set these guys up and end up solving those. I don't want to leave you without those being solved in there. And let's see, we'll put that back in there. Okay, everybody has this sheet? Anybody need it? I think everybody was here last time, so I think everybody has it. Okay, so we got to start down here in 7.6, not up in the other parts there. It says if y is directly proportional to x cubed, when y equals 54, then x when x equals 3. What is y if x equals 6? So let's see if we can set this whole thing up. So again, directly. What's directly mean? Directly means multiply. Yep. So because it means to multiply in there, we need to first, of course, set up our problem based on that. And so if we set up that problem, we are going to have y is equal to k times x cubed. And this one's like one we solved earlier. Then read my next piece. When y equals 54 and x equals 3. Again, don't try to read beyond pieces in here because you want to break it apart. So then, if I plug it back in, I will find out that y equals, well, we have to plug in y, so 54 equals k times 3 squared, or cubed, sorry. So I get 54 is equal to 27k. Divide by 27, and I find that k is equal to 2. And then finally the last piece, what is y if x equals 6? So if I plug it back in, I know k is 2, so what's y going to be when I have 2 times 6 cubed? So what would y equal? And then I need to solve it from there. So what do I get? Well, I get 6 cubed times 2. And, whoops, that wasn't what I wanted. 6 cubed times 2. And I get 432. We all get that okay? Okay, good. All right, then go to the next one. The volume of gas in a piston cylinder varies inversely as the pressure from the piston on the gas. Now this one doesn't tell us letters in here. It says if a gas has a volume of 180 cubic inches under pressure of 6 pounds per square inch, what will be the volume if the pressure is increased to 8 pounds? So in some of these, you need to assign them letters, and you need to assign them what they'd end up meaning. So you got the volume of gas in a piston cylinder varies inversely as the pressure from the piston on the gas. So what does that mean? What can I assign letters to? What was that? Yep. So it's division. We know that part. But we got to set up our equation. We need some letters in here. And probably a week or so ago, 2 weeks ago, I guess it was, I said if we can assign letters that mean something, then we have a better chance of plugging stuff in. So because this is talking about volume, what would I probably use? V. And then it says about pressure. So I'd probably end up using P for pressure. Perfect. Yep. And so my equation would then start looking like volume equals K over P. And because it's inversely, and it means division, we know that that's what we have to have. So then, if I read the second part that tells me what numbers I have to put in, now I got to figure out what number goes where. If a gas has a volume of 180 cubic inches under pressure of 6 pounds per square inch, so that kind of tells me where stuff goes, because volume of 180, pressure of 6, so that kind of gives me a clue as to my pieces in here. So now I need to solve for K, so 180 times 6, and leave that on your calculator because we're going to work with it again. So K equals 1080. And then if I go to my third piece and I solve it, so my third piece is what is the volume of the pressure when it's at 8 pounds. So that means I'm going to have volume equals 1080 all divided by 8. And if you don't take it off your calculator and leave it right there, all you got to do is simply just stick it on there and you get 135 cubic inches. Okay, make sense? You finding these not so bad? They're all spelled out for you. You just have to read and watch where your pieces go. Another varies inversely. So if we look at this one, what happens with it? It says if y varies inversely as x and y, so that's my first piece. Or inversely is x. I guess I just want to go that far. And y equals a negative 49 and x equals 32. So my first equation is y equals k over x, because it's inversely. Plug in my values. 49 equals k over 32. Solve that. And then finally, we need to figure out our last pieces there. It says find y if x equals 9. What was that? Oh, yep, thank you. That would make a big difference in my answer. So negative 49 times 32. Again, leave it on your calculator. K will equal a negative 1568. And then set up my new problem, which is y equals a negative 1568 all over 9. And we find out that y is equal to a negative 174.22, because it says round to the nearest hundredth. Be real careful to read that piece. If it says round somewhere, make sure you round it, or it will mark it wrong for you. Okay, so watch and make sure you get that part out of there. Okay, questions with inversely. Inversely again means, of course, division. So make sure you divide it. And then we got another one on here that's a jointly. So let's take a look at that one. It says z is jointly proportional to x squared and y squared. If z equals 500 when x equals 4 and y equals 8, find z when x equals 7 and y equals 7. So we first need to, again, get my formula. Since it said jointly, what does that mean? Jointly means I'm gonna have two multiplications. Okay, so z equals k times x squared times y squared. Plugging in my numbers, 500 equals k times 4 squared and 8 squared. That's the next piece. So, we got to find k. So, 4 squared times 8 squared. Then I want to take 500 and divide it by that answer, which is 1024. And I get k is equal to 0.489 or 488.28125. Leave it on your calculator because then we're going to do 7 and 7. So that number times 7 squared times 7 squared. And my final answer for my new value of z is going to be 1172.36. So that would be my finished answer for that one. Okay, so does that make sense? Hopefully. Okay. And so you want to watch those things and see what happens with them. And one more. You guys work on this one. Oh, the last one? Sure, I can do that. Yep, here's the answer for the last one. Whoops, that wasn't the last one. There's the last one. And my pile of notes here. Is that okay? Okay, yep. Oh, the second. Oh, this one? You write it out? Oh, okay. Yeah, we'll go up here. So it's going to be z equals k, which is the 0.488 times 7 squared times 7 squared. Okay, that help? Good. Yep. No, I shortchanged you because I kind of ran out of room and I should not have shortchanged you. But that's what it would end up looking like. But this again, if you leave k what it came out to be on your calculator, then you're good to go. Okay, don't take this k off your calculator because you're going to use it in that final step. Okay, so leave k on there. So let's see what we get for this thing. And I should just have far, not with an E on there. You guys see that in the back? Of course, you got it on your papers in the back row, so I guess we're good to go. that part. So anybody figure out what K is? What's K going to equal in this problem? So our formula, a distance that a free-falling object falls is directly proportional to the square of the time it falls. So that means I have distance equals K times time squared. That's my formula. That's from the very first sentence. Then I need to plug in some numbers. So I put 42 is equal to K times 7 squared and solve for K. And I find out that K is equal to 6/7. So if you had that on your calculator, it will be a decimal. So it would be 6 divided by 7. Or K, if you do use your calculator, would be 0.85714285771. Okay? So leave it on your calculator. Don't remove it, because then you go back and end up finishing it by plugging in how far will it have fallen after 8 seconds. So I will have distance equals my K times 8 squared, and I will find out that my distance is 54.86 feet. So that would be my distance. Get that to work out? Okay, so as long as that's what we have. All right, there is one type that puts all of these variations together into one problem, and I want to do that one because I don't want to leave you without having one that has everything in it. So, we good to move this one? Not quite yet? Okay, can I move it? Okay, it's gone. So, let's take a look at this one, and let's see what we end up with for an answer with that one. It says, a safe load L of a wooden beam supported at both ends varies jointly as the width W and the square of the depth D, and inversely as length L. Lots in that one. A 3-inch wide by 10-inch deep beam that is 8 feet long supports a load of 9,600 pounds safely. What is the safe load of a beam of the same material that is 4 inches wide, 9 inches deep, and 12 feet long? So we got to come up with what our equation happens to be. So the safe load of a wood beam supported at both ends varies jointly with the width and the square of the length of the depth, and inversely to the length. So what in the world does that look like? So we've got some words in here, jointly. So we know we got 2 multiplications going on. We have inversely, which means we have a what? Division. And so setting this up, we just got to go through and get our letters. The load L of a wooden beam supported at both ends varies jointly as the width and the square of the depth. So we want d squared all over the length L. Okay, now I need to plug in my pieces. So the next sentence, a 3-inch width by 10-inch deep beam that has 8 feet long supports 9,600 pounds safely. So that means I have 9,600 pounds is the load. K times the width. The width is 3. The depth of the beam, which needs to be squared, all over the length of the beam, which is 8. So then we have to figure out what comes out of that. So that would be K. And again, leave it on your calculator because we're going to use it in a second here. So multiplication on top gives me 9,600 is equal to 10 squared, which is 100, times 3 is 300, all over 8. So 9,600 divided by 8, to remove the 8 off of here. Then I'm going to take that answer, not divide it, times it. Sorry, I misspoke myself there. 9,600 times 8 divided by 300 will give me K is 256. And then from 256, we are going to use that with my next piece. And it says, what is the safe load of a beam with the same material that is 4 inches wide, 9 inches deep, and 12 feet long? So we need to find load. So we're going to plug those pieces back in. So I got K, which is 256, times my width, which is 4, times my depth squared, all over my length of 12. So 256 times 4 times 9 squared equals, divide that by 12, and I get my new load. So my new load is 6,912 pounds of load. Okay, so I just wanted you to see one that has all of the different pieces that are in there and so forth with that. So it's part of your answer. Okay, anything else with these? We need to do more? Are you good? Think you're good? Okay, pay attention to jointly, inversely, and directly. Those are your key. Directly multiplication, inversely division, and jointly means you got some double combinations of stuff going on in there. Okay, good. So as long as we got that. Also in the video there is going to be, or not in video, but in the notes, there are some extra problems in here. I will go through and work those out, so they would be in the back part of your notes. So usually everything that's in your notes gets worked out. So these are in there. I don't think we need to necessarily go through them because I think you got it of what we've got going with that. So that's where we're at with that. Okay, so that takes care of this piece. So let me stop the recording.